So in this video we are going to discuss about high voltage, precautions, safeties, advantages. Very important question, and your couple of questions, oral questions, will get covered, which the surveyor is asking in whether in MU class 2 or MU class 4, that will get covered over here. So let's begin our topic. In industrial practices, that is the category of high voltage. I will not read, it's just self-explanatory. The figures, low voltage, medium voltage, high voltage. What is high voltage system in marine application? What we are more focused on? Voltages up to 1000 and including, that is low voltage, and above 1000 volt, that is high voltage in marine application. Now remember this power equation. Now you see, you must have studied Ohm's law in your school days. For a given power, higher the voltage, lesser is the current. See why we are discussing current again and again. So see, as per Ohm's law, it is power is equal to voltage into current. Okay, power is equal to voltage into current. Now why we are discussing this current is important, because everything, if you see, you will be able to, the losses in the conductor or anywhere in electrical system, you will be able to relate it to the current. Other advantages follows, but it is able to directly relate to. So what we are more focused is to reduce the current. So how we are going to reduce the current? Because power is directly proportional to voltage as well as current. So we are, what is going to do is, we are going to lower the current by increasing the voltage. So how we achieve the advantage, you can see here. So for same 440 kilowatt, what we are getting is 1000 amps. For 1100 1.1 kilovolts, we are getting 400 amps, that is 11 kilovolts, we are getting 40 amps. See how drastically the ampere has reduced. So anywhere this picture should come in your mind, ki higher the voltage, lesser is the current, and that is the power equation, Ohm's law. So advantage of high voltage, this is the first thing that should come to your mind. Now when we speak about what are the other advantages because of current, because of lower current, other advantages that follows is reduction in the size of the cable, etc. for a given power, saving of space, weight, reduction in cost of installation, ease of installation, reduction in short circuit level in the system. Short circuit level system will reduce. Now see, because of this short circuit only, your motor is drawing more current, and we have, that is the reason why we have short circuit protection. In a very lesser time, the motor draws this current. Now you see here, they are calculating this fault level. Okay, for the same, see, for 1000 kVA, that is 415 volt. Okay, for the same 1000 kVA, that the voltage we have increased, same for the same three phase. You see here 88 amps, here you have 1400 amps. So that is the fault level. Now if there is advantage, there will be disadvantage. Higher insulation requirement for cables and equipment used in the system, because we are supposed to protect the personnel, and that is the reason your cost is going to come into picture. Higher risk factor and the necessity of strict adherence to stringent safety procedures. Okay, creepage distance. Now when we speak about this creepage, you must be familiar about creepage. Creepage is nothing but is the shortest distance, you can say, shortest distance between two conductive parts or parts along the surface of an insulating material. Okay, so that is the C, creepage path, RYB. Higher the voltage, greater will be the clearance creepage distance. So clearance will be more, this clearance will be more, the creepage distance will be more. This is the idea. This is the bus bar, metal support, insulator, that is the creepage path that we are discussing. Okay, what are the major risks involved in high voltage systems? So when we speak about major high risk, high inter electrode capacitance present in high voltage system, stored energy in high voltage inductance, arcing, sparks and creepage, tracking due to moisture, low insulation, loose connections, etc. A typical power cable. Now you see high voltage power cable. You see the outer sheath, and then we have galvanized steel wire braiding. You have this galvanized steel wire braiding that is present over there, and then you have what is known as your this is the outer sheath, galvanized steel wire braiding, and then you have earth wire spun out of braiding. This is the earth wire. Then you have this inner sheet, then you have core insulation, and then we have what is known as separate cores. They are also covered. How they are connected: T1 is the charging time, T2 is the discharging time. Interelectrode capacitance: two conductors of electricity electrodes separated by an insulating material, that is two adjacent core in a power cable, from a capacitor while carrying an electrical current. This is called an interelectrode capacitance. While carrying an alternating current, they charge and discharge during each half cycle. The charging and discharging time of these interelectrode capacitors increases the voltage between the conductors. Higher the voltage, longer is the time for charging and discharging. The cores of a high voltage power cable retain their charge for a longer time even after the circuit is de-energized, posing a grave risk to anyone who comes in the accidental contact with the conductors after the circuit has been switched off or de-energized. So that is the disadvantage. It is of paramount importance to ensure that conductors carrying high voltage currents are not only switched off but also earthed, and the charge held by them discharged fully before allowing anyone to come in contact with the conductors. When we speak about high voltage inductance, a large amount of self-induced and mutually induced voltage in the inductive load, example motor and transformer winding, take time to discharge these voltages even after switching off the load and pose a safety risk similar to inter-electrode capacitance. Okay. Now high voltage circuit breaker may be air circuit breaker, gas brake, or vacuum brake. Most popularly we are using is vacuum breaker. High voltage vacuum breakers are also used as high voltage contactors for motor control. Okay, vacuum interrupter, one phase. You can see here, this is the ceramic insulation, capacity travel, breaker plugged in with auxiliary contact in the main contact. When we are drawing out the breaker, this we have fixed contact. What are the advantages? Why we are using this vacuum circuit breaker? Vacuum has a high dielectric strength and ensures a shorter contact travel due to high dielectric strength of the vacuum and a shorter arcing time, resulting in the lower arc energy. The above feature ensures the following: compact, quiet unit, minimum clearance, non-flammable and non-toxic. Contacts suffer lesser wear, thereby ensuring longer life of the breaker. Insulation integrity of the vacuum can be checked by a voltage impulse tester, which produces a short duration voltage pulse, usually twice the rated voltage of the breaker. A weak insulation of the vacuum will be detected as a current flow. Lower the insulation strength, higher will be this current. Lower the insulation strength, higher will be this current. Now when we speak about this SF6 breaker, this is the operating mechanism. Main contact, arcing chamber, sealed chamber, SF6 gas, the epoxy resin case. IR tests of high voltage equipment. A 5000 volt DC megar hand cranking or electronic can be used for equipments up to 6.6 kilovolt. For routine testing of IR, DC must be applied for 1 minute either by cranking at constant speed with a hand cranking megar or by maintaining a 5000 volt DC continuously by a PV in the electronic megar. A prescribed interval, and particularly after a major repair work on equipment or switch gear, a polarization index, that is PI, may be taken to assess the condition of insulation of the equipment. We will see what is polarization index separately. Issued by authorized person, responsible person who perform the task for repair maintenance, generally valid only 24-hour, permit to be revalidated if work extends beyond 24 hours after use. Formats will vary and be customized for a particular vessel marine installation. Permit to work board guidelines prepared in carbon copy, duplicate, and has all at least 5 sections. First section states the nature of work to be carried out. Second section declares where the electrical isolation and earthing have been applied and where dangers caution notices have been displayed. Third section is signed by the person receiving the permit, acknowledging that he is satisfied with the safety precautions taken and the isolation earthing measures adopted. Fourth section is signed by the permit holder that the work has been completed, suspended. Fifth section is signed by the issuing authority cancelling the permit. So that is the format of your permit to work. Sanction to test safety certificate. When it is required to test a high voltage equipment using a low voltage control supply, it will be necessary to isolate the equipment from the main high voltage supply but remove the earthing. Okay. In these circumstances, a sanction to test safety certificate is to be obtained from the authorized person. See, high voltage line tester you see here, coincide clip for earth connector. This is the test providing unit, and then long distance shaft high voltage indicator. This is the handle that is there, and then portable earthing connectors we have. These are the portable earthing connectors. Clamps we have. Typical earthing straps rated for use up to 11 kV with current withstand of kiloamps 1 second. As in low voltage system, overall system protection in a high voltage system is supervised by electromagnetic or static relays. These relays are checked annually or as required using either a primary injection test or secondary injection test. Now, what is polarization index? A PI test is conducted on the equipment when the routine IR value tests are doubtful or during annual refit or after major repair are undertaken. When we are not satisfied with IR test, then we do this PI. PI value is the ratio between the IR value recorded after application of the test voltage continuously for 10 minutes to the value recorded after 1 minute of application. So it is basically a ratio of IR value at two different interval of time, you can say. That is the polarization index. A PI value of 2 is considered satisfactory. A maser driven measure is essentially for carrying out a PI test. A motor driven measure is essentially for carrying out a PI test. See the MSP with electrical propulsion. This is the basic diagram. I'll just pause for a while. Okay. So that is the whole idea. So in this media we saw high voltage system. What are the advantages? What is the range of high voltage system in industry? What is the range of high voltage system in your marine application? What is low voltage and what is high voltage? Why we are more bothered about high voltage system in marine application? How these are advantageous? Why the current comes in picture, and how current is reduced when your voltage is using the power factor for the same power of the motor. When you increase the voltage, your current is going to reduce drastically. So that is the reason why we are more concerned about high voltage. Then we saw advantages and disadvantages of high voltage system. Okay, then we moved on, and then we saw polarization index, resistance, IR value, how we calculate polarization index, and all these things. We also saw here Ohm's law. Based on that, we calculated for a same rating of motor, if we increase the voltage, how current is reducing. Okay, we saw the breakers used here, vacuum circuit breakers and all. I hope it is clear for you. Thank you so much. Thank you for your valuable time. Have a wonderful day ahead.